Hello, welcome to Tech Transform. In this session, we are going to cover Spark core concept. So Spark is mainly built on the backbone of the Spark is RDD, that is called Resilient Distributed Dataset. We are going to understand how what is actually RDD is and what the internals work of it. And let's quickly dive into that. What is RDD? So Spark RDD is basically it's a resilient distributed dataset. Resilience, you can say, let's say your one of the node gets down, and this RDD becomes it's a fault tolerance, and Spark internally runs a program, and it will automatically it will give you a feeling like that nothing has been happened. It can resume from there it left off. Distributed means this RDD is basically distributed to among a lot of clusters of nodes. Your data is, let's say you have a giant data set, and it is RDD is basically it's distributed among different nodes and on small chunks of data to the data set. And data set is nothing, is just holding all the data. What are the complex things is behind the scene Spark is doing it, that will be abstract to the user. So you have the data set, that is you can work it like you're working with a normal table or normal data set. So that's what the Spark RDD comes. So this is very powerful and base of the Spark. How are you going to create this RDD? Basically, Spark framework provide you a Spark context class. One, if you want to create a RDD, first you have to create a Spark context. You have to create an object of a Spark context. Then you will get a object of a Spark context. Then you will do dot. Then you can get the RDD. So it's created by driver program itself. You can get it by Spark context equal new Spark context. This is the main Spark context class is responsible for making RDDs resilient and distributed. Resilient means fault tolerance. Distributed means chunks of small massive data sets distributed in small chunks of data to the different nodes. So that's the distributed concept. It is also responsible for creating RDDs. Basically, once if you create Spark context, then only you can create RDDs. But what happens in Spark cell when you are working with a Spark cell? This Spark cell is automatically creates a SE object for you. You don't have to create instance of that Spark context object in order to get the SE object. This will be already automatically it will be created for you. So you can see how we can create the RDDs. Let's say we have a number called val nums. Either this is a list of two type of inputs it is going to take. Either it can be a static list like this. I am giving list of 1 2 3 4 either, or also it can take data from any text file or any data sitting on Amazon S3 or data sitting on SDFS distributed file system. So it can connect to anything. So two ways it can connect. Basically it's parallelize. If you do sc.parallelize, it will take the hard-coded input and it will create a RDD for that. So this nums is nothing but a RDD object. This sc.text file is also you have to give the text file of the text path from where you want to load the data. So this whole expression will again give you a RDD. Either let's say your data is sitting on Hadoop cluster and you want to run your Hive query. You can do you can run your Hive query directly from Spark, and you can create RDDs out of your Hive table. So for that you can use Hive context, and Hive context you have to pass Spark context. Then you will be getting a Hive context. Then you can do Hive context.sql. Then the actual Hive query you want to you can write here. Let's say select name is from the users. This tables is in your Hive table. So you can do a lot of stuff using RDD. So this rows is nothing again, it's a RDD. Also you can create RDD from either JDBC driver. You can connect to Cassandra, and you can take sorry, the spelling is it's Cassandra, Cassandra. So it can connect to Cassandra, and it can give you the RDD. Also it can connect to HBase, Elasticsearch. It can connect to a static file like JSON, CSV, sequence files, object files, or various compressed formats. Basically, once we get the RDDs, we are going to perform two set of operations always. Either two set of operations always involved with RDD. Either you can transform or either you can perform actions. So we are going to look in detail what are the transformation and action. So remember, there will be always two concepts with RDDs: transform and action. Transforming means you're transforming your data as you want, and uh, actions means you are going to perform some final actions. You're going to collect the result, you're going to count the results, something like that. The final actions is going to perform after transformation. The first thing is transforming RDD. So these are the methods available in order to transform your RDDs. Transform your RDDs means, let's say you got your data from text file. Let's say you have a 5 columns inside that. It's a n number of a lot of rows inside that text file, and each row is containing separated by, let's say, comma, and having five comma separated values. And you can think 1,000 of rows having 5 columns with comma separated. So you want to perform, let's say you want to get only two fields from that 5 columns. For that you have to apply transformations. So that RDD is going to consist that will be your raw RDD. Then you have to perform your let's say you want to perform actions on each row. Then you have to use map function. Map function is basically, it is going and getting applied on each rows of your RDDs. So you can think of RDD as a set of rows having a number of columns associated with a comma. Either it will be comma separated, tab delimited, or any separated delimited. So map, you have to perform, let's say I want to perform operations on each row, so I will be using map, and my output I know also the same number. So I applied let's say I applied operation on 100 rows. The output RDDs is also containing the 100 rows. So in that way we are going to means one to one relation will be there. Then we are going to use map function. Flat map is, let's say you want to 4 to 5 rows you want to reduce to one row, means many to one relationship will be there. You want to apply the transformation where it is going to take 4 rows and convert it to single row, so many to one. So in that case you're going to use flat map transformation methods. Filter is straightforward. You want to filter your rows based upon some criteria or condition. It is going to neglect those rows based upon your criteria. Distinct, let's say your RDD is going to contain a lot of distinct rows. If you want to get your RDD is going to contain the duplicate rows, and you want to get the distinct rows, you can apply distinct and you can get the distinct records. Sample, let's say you have a very big data set and you want to, this sample is basically used in testing. So let's say your data set is very massive and you want some sample out of from that data set. In that case, sample is a random. It will be giving you test data, some part of your data set as a testing data for using sample transformations. You can do union, you can do intersection, you can do subtract, you can do Cartesian. So these are the transformations we can perform. So let's understand what has happened in the map function internally. Let's say we created a RDD, means we are passing the hard-coded values of list 1 2 3 4. For that, sc.parallelize. If we want to load data from external text file, then we have to use sc.textfile. So we are using hard-coded list. That why we are using sc.parallelize. So this will give you RDD object. Then let's say I want to perform action on each element of this list. For that, means I know this the list contains 4 items. I'm going to apply I'm going to apply a transformation in each element, and I know the resulting list RDD is also going to contain these 4 items also, means one to one relations. So let's say here what I'm going to do RDD.map x goes to this anonymous function, inline function. This is a functional programming. X star x means what we are going to apply, we are going to multiply x star x on each element, means we are going to calculate a square of each element. What it will yield finally? 1496. Means you have started with this RDD, now you have squares RDD containing this set, 1496. So that's how you perform one-to-one operations on each element. Then we choose map transformation. So that's the map example. In later video, as we progress, we are going to see a lot of transformations in actions. Okay. So this you can understand in functional programming concept also. Many RDD methods accept function as a parameter, as it accepts function as a parameter. This is called function as a parameters. So this RDD.map is equal to x star x is the same thing as when we create a function in Scala, something like that. Def square it, then my input to this square it method is item of integer type, and output is also integer. What we are going to perform this expression return x star x, means we are passing x and we are returning the square of that particular x. So same thing you can do like this also, rdd.map, and you can pass the method itself. So what it is going to do, this rdd.map, it is going to call this square it method on each items of your RDD, and it will give you a new set of RDD. So this again, this RDD is raw RDD, and this will give us a new RDD containing the square of the numbers. Okay, so that's the functional programming concept also. So we saw the transformations, and then the next thing is action. So after performing various transformations in order to achieve what you want to achieve for that particular problem, then you have to apply action. And remember, in Spark, whenever you are not applying actions, your result is never going to execute it. Means, let's say you have did 10 transformations in your RDD, but it is not going to fetch any result unless until you are calling actions on them. So for that, that is why RDD is called lazy evolution. It is not going to execute unless until you are going to call the actions. Till that, it is just keeping a source code for you. Internally, it is not it's not fetching any data or not doing any operation unless until we call this any of the actions you are saying. Collect is basically, let's say you have performed certain transformations, and finally you got a RDD. Then you want your result back to your driver program. In that case, you use collect. So it will fetch you all the results. It will go, and finally, if you are doing collect, so a lot of things happening behind the scene. Spark, what it will do, it will, let's say you have performed 8 operations, 8 transformations. Spark will internally going to create a direct cyclic graph for this particular transformations, and it is going to utilize the optimum solution for that particular all the transformations, and it will collect all the results, final results, and it will give back to the driver program. Count, then the next thing is count. If you want to count, let's say number of record in a RDD, it is going to perform, and it will give you count by value. Let's say you have a duplicate rows inside RDD, and you want to count specifically on certain value. So you want unique rows, number of rows available for that particular value in a RDD. Take is also, let's say you have created your RDD and you want to quickly check what are the schema is, and let's say you want to print only 5 rows from the RDD rather than printing entire. For the testing purpose, you can check in a console for that. Take actions is there. Top is also similar. Reduce is basically you want to chuckle it down some data. Let's say you want to reduce your operation. Let's say you have a x and y in each row. What you want to do, you want to do x plus y and return into a different column, let's say z. So what you're doing, you're reducing 2 columns and getting back one new column. So that's how you're performing the reduce operation. There are some more actions are there. As we are going to perform work in future, we are going to see that. Lazy evaluations. In a Spark, basically nothing actually happens in your driver program until an action is called. Means unless until you're calling a transformation is fine. You're doing all your work. You're transforming your data as you want. You're giving a schema of to your data as you want. But unless until you're not calling an action on RDD, it's not going to evaluate. It's not going to fetch any result. So that's why Spark RDD is lazy evaluation, and it's pretty good for also. Let's say we are transforming a lot of transformation we are doing in between. Let's say it's going to execute. It's not good thing for performance point of view. Every line you're transforming and you're fetching all the result and actually doing the calculation behind the scene, rather than let's say you have done 7 to 8 operations and at one time you're going to execute, and direct acyclic graph or linear graph is going to construct for you by Spark, and it will give you it will find a optimal solution for that behind the scene, and it will give you the result as much fast as it can. So that's how the lazy evaluation concept in Spark. So we have seen a lot of things of the RDD, how the internals of the RDD works. We are going to come up with a lot of practical example in futures sessions where we are going to actually create a RDDs, and where we are going to actually solving a problem and how RDD is helping us. So that's all for this video. Thanks for watching. Have a good day. Bye.